Hello, welcome to my YouTube channel. My name is Nenye Abraham. I'm a graduate of Kwame Nkrumah University of Science and Technology, West Africa, to be precise, Ghana. Today, I want to take you through a part of mathematics called differentiation. Now, we have started a series of mathematics lessons under a topic, calculus. And then we have learned several things from this topic even up to now. And today we are going to a part in differentiation called differentiation from the first principle. Please kindly subscribe to my YouTube channel if today is your first time of visiting this channel. Now we have differentiation. Differentiation is all about measuring change. It's all about measuring change. Now, when we talk about differentiation, it's all about how to measure change. I think in my introduction to calculus, I did mention about what calculus meant. And differentiation is a branch of what? Calculus. It's a branch of calculus, and it's just almost the same as calculus, but a part of calculus. So it's just all about how we measure what changes, how we measure changes, the movement from one place to another, what are the changes in time or in rates. Now, measuring changes in a linear function, change in a linear function. Now, we always differentiate a function with respect to something. Now, in differentiation, we always differentiate a function with respect to some changes or something. If you have a function, given a function, let's say given a function y equal to x, let's say x squared. Given this function, now we always differentiate with respect to something. If you have been given to differentiate this function, then you need to differentiate it with respect to something. If you are differentiating with respect to, you can be asked to differentiate with respect to y or respect to what? X. So whatever you are being asked to differentiate to here should be differentiated. So we always differentiate with respect to what? To something. So differentiation from what? First principle. When a function is given to differentiate, there are several ways we can do that. So when a function is given to differentiate, there are several ways we can differentiate it. But we must all arrive at the same answer with whatever method we employ. So whatever method we employ into this differentiation, we must all arrive at the same answer. So you don't say that because I use this method, that is why I had different answer. Whatever method you use in differentiation, you should get the same answer. So in differentiation using the first principle, this is what we are looking for. We are looking for change of what? Y over change of x. And I stated something here. I stated that dy dx is equal to this. Now dy dx is change of y over change of x. Dy dx is change of what? Y over change of x. And then it is equal to what? Y minus what? Y2 minus y1 all over what? X2 minus what? X1. And we all know this in mathematics. When you have something like this, it is called what? Gradient. It is called gradient. So in differentiation, what we are looking for is a gradient of maybe a curve or a linear function, a linear function, or we are looking for something. We are looking for a change in something. So in differentiation, here what we are looking for using the first principle is the limit where change of x is approaching what? 0. Change of x is approaching 0. The limit where change of x is approaching 0. dy over what? Dx. This is what we are looking for in a function which we are differentiating. So let's look at this. For example, if you are being given a function to be, let's say y equal to ax, y equal to ax. Now dy means that we are differentiating y, or the function, with respect to what? X. Whatever you are differentiating with respect to should be the denominator. So because we are differentiating with respect to, because I stated at the first part of this lesson that we always differentiate with respect to something. So here we are differentiating with respect to what? X. And so you have change of x at the bottom. For instance, if we were differentiating with respect to y, then y would have been at the bottom, and what? The change of what? Y should approach what? 0. The change of y should approach what? 0. For example, we are differentiating this with respect to what? With respect to x, and with respect to x, we are differentiating this with respect to x. So using the what? The first principle, that is what we are learning. So if you are differentiating this with respect to x, what you need to say is that let y equal to y plus change of y, and then x equal to x plus change of x. So it means that in the equation or in the function, whenever you see x, you now substitute what? X plus change of x, and whenever you see y, you substitute y plus change of what? Y. So here we have y, so we'll now write what? Y plus change of what? Y. Y plus change of y. That is, in our function here we have y first, which is equal to here a, and then x. It will be what? X plus change of x. Now we all realize that we are looking for what? Dy over dx. We are looking for dy over dx. So what you do is that you expand this thing, so it will be y plus change of y equal to ax plus a change of x. A change of x. Now if you're having this, what do you do again? And we are looking for dy. We have to make dy the subject. So dy is equal to ax plus a change of x minus y. But we know from the question given, we know from the question given that y is equal to what? Ax. We know that y is equal to what? Ax from the question given. So you substitute that, but y is equal to ax from the question given. You substitute that, so it will be y equal to, change of y equal to ax plus a change of x minus ax. Now we realize that this our ax will cancel this one, leaving change of y is equal to a change of x. Now we are looking for change of y over change of x. So it will be change of y divided by change of x equal to a change of x over change of x. If you do this, the change of x will cancel change of x, and your change of y over change of x is equal to a. But we know that we said we are looking for lim where change of what you are differentiating with respect to will approach 0. So we are differentiating with respect to what? X. So change of x is equal to 0. There's no change of x here. We would have substituted what? 0 inside, just like we did in the what? In the limit in my first lesson when I spoke about limits of functions. We said something about that. And so this is the answer you will get. Now let's look at the second example. The second example. For example, if you are having, let's say, y is equal to x squared, ax squared. So let y equal to y plus change of y and x equal to x plus change of x. Now if you pick your question, it will now be y plus change of y equal to a multiplied by x plus change of x all square. Now if you expand the bracket at the other side, it will be equal to a still multiplying x squared plus 2x dx plus dx square plus this dx square. Now let's expand dy, y plus dy is equal to ax square plus 2ax dx plus dx, so a dx square, like this. Please, I hope you understand. If you don't understand, please pause it and look at it very well. Now let's make the y stand alone, because that is what we are looking for, to come and stand alone first. Then we send y at the other side. When you do that, this is what you have. The y is equal to ax squared plus 2ax dx plus a dx square minus y. But we know that our y is equal to ax squared from the question. So substitute that in place of what? Y. So you now have the y is equal to ax squared plus 2ax dx, that is change of x, plus a change of x squared minus our y, which is now ax squared, like this. We can all see that this can take away this, and then our change of y will now be equal to 2ax change of x plus a change of x square, change of x square. So if you are having this, we see that we are looking for change of y over change of x. So what can we do? Let's factorize change of x from the other side. When you factorize change of x from this side or out of this side, it will now be 2ax plus a change of x. Divide both sides by change of x, here by change of x, and your dy, your change of y over change of x will be equal to, this will cancel out this, and it will be equal to 2ax plus a change of x. Now we said that we should always let, this is what we are looking for, lim change of x approaching 0. We are looking for lim change of x equal to 0, change of y, change of x. It means that in the equation, wherever you see change of what, x again, substitute it as 0 in the function. So this function will be equals to 2ax plus a multiplied by 0, and it will be equals to what, 2ax. So now we can now say that our lim where change of x is equal to 0, change of y over change of x is the answer. And this is just a sample to illustrate how to solve first principle, method of first principle in calculus. Thank you very, very much for listening to my video. Please subscribe if today is your first time of visiting this channel. Thank you.